Hi, everyone, and thanks for coming to our webinar. My name is Eliza Berry. I'm Marketing Director of Richey May Technology Solutions. And today I'll be helping out with kind of the technical side of the webinar. So if you have any questions, be sure to type them either in the questions panel or in the chat box, and I will either help you ask those at the end, or I'll just connect you with either JT or Mark or Janine after the call if it's a little bit more of a long question or specific to your company. So we're going to be talking about automating AppSec to secure your app stack and beat the bots at their own game. After the webinar is over, we will send out a recording to everyone and the slides. So if you are joining us live, then that'll be sent straight to your email box, or if you were registered, or if you're joining us online, then we will link the slides below this video. So without further ado, I want to hand it over to JT Galletto. He's the Executive Director of Cybersecurity with Richey May Technology Solutions, and he's going to talk to you a little bit about some of the trends in the industry right now. So take it away, JT.
Thanks, Eliza, and thanks everybody for joining us today. So, some of the things that we're going to talk about today, we're going to talk about some of the different trends and threats that are going on in the industry, and then Mark from ThreatX is going to talk about how some of these attacks work, and a number of different case studies from actual real-world incidents, and putting together a strategy on how organizations can actually better secure their online applications, the APIs, and different things that we may use within the media and entertainment space from a content protection and workflow perspective. So, why is this such a hot topic? And one of the things that I like to talk with folks in the media and entertainment space is that as we continue to see revenues grow from video on demand or over-the-top services, the bad guys are going to continue to target those services. And the way that they're going to target them, and we'll get into that later, does vary. But why? And it's because when we look at the trends, the market growth for video on demand or streaming services is expected to grow to reach $33 billion by 2023, and that's over the course of the next, at this point, 3 years. And what's happening is, from a threat landscape perspective, is that the bad guys are trying to leverage our services and our resources against us, right? And stealing credentials is really the number one threat vector. And I know that many of these platforms are working towards better securing those assets and controlling those credentials. But as an organization, we have to also understand that we're being faced with losing our username and passwords either through phishing attacks and other things like that. But once those credentials are out there, that's really an attack vector against our application sets and in our digital workflows. And when you start looking at this, it's not just humans bashing on keyboards, right? Automation, as we automate our workflows to move content through our production cycles, the bad guys are using automation as well. And what's interesting is that when you start looking at automation and what's going on there, it's not just a good bot versus a bad bot. It's really looking at nearly 40% of that traffic is actually automation, right? 40% of the traffic that we're seeing hit our web-based applications is all automation. And that automation could be good or bad, right? Some of it's for indexing, right? And putting a higher profile on our services and offerings, and others is trying to find weaknesses. And when you start looking at how does this really boil down to the media entertainment space as a whole, right? Distill Networks did an interesting report in 2019, and we start looking at the way they broke their report down from a ticketing perspective, the adult entertainment industry, as well as digital publishing. Those three areas are being targeted by bots quite a bit, right? And when you start looking at the bad bots piece of that, especially when it comes to ticketing and some of those other entertainment services, that's again nearly 40% of the traffic that's hitting that. And so it is definitely something that we need to be more aware of, and how we design and develop our applications and the different controls that we leverage to protect those applications. And with that, I'd like to ask Mark to talk a little bit about that and how we can best protect our organizations.
All right, thanks, JT. Thanks for everybody that joined on the webcast as well. So we're going to talk through a couple different things. We're going to talk about automated attacks, specifically from botnets, how they work, and then also what's the motivation behind these attacks. So, no real surprise here. We talk about these malicious attacks. We're really talking about trying to impersonate legitimate users of your web application with a automated framework that allows to create attacks. So taking some of that functionality that's intended for valid users and trying to see if there's ways to circumvent that or to game the system. So whether that's form fields where it's user registration, comment forums, straight up login, those are the main targets that we see. These kind of attacks have become incredibly easy because with the advent of cloud providers, it's easy to and relatively inexpensive to build networks of attackers so that we're getting coordinated attack that looks as though it's coming at us from different IP addresses, even though that's a single bot or botnet network. So another problem that we've got is that our traditional tools are not very good at detecting these type of attacks when it's a distributed attack. So we need to really move beyond what it is that we've been historically using, where we're looking at individual IPs, we're looking at things at the transaction level and making yes/no decisions based on individual transactions. So what are the motivations behind these attacks? So again, this is not incredibly surprising, but the app data or the site data is one of the big targets. So whether that's competitive scraping information, we see this quite a bit if it's pricing or availability. This is one of the reasons that a lot of online merchants won't show you the price of something until you're actually in the shopping cart ready to check out. So that folks, competitors in particular, are not out there scraping prices just so that they can come in slightly below that amount. Then the other is the second thing that we see is in order to beat the actual human. So whether that's being able to buy up a limited supply of tickets, retail, we see this with some of the hot gifts around Christmas time. Any place where you can introduce scarcity by being able to, in an automated fashion, buy up something that's in high demand. Third thing we see, and this is the one that kind of makes the news more often than not, is the theft of credit card information. So we've seen credit card information just on the dark web. We've seen valid credit card numbers a decline in that black market price. It wasn't that long ago that they were $80 and $100 per credit card. We've seen that number dip below $30 and sometime down in the high teens, depending on the quality of the credit cards that have been stolen. One thing that we do see is a trend away from this being the main target, and we really see healthcare information and other personally identifiable information being a bigger and bigger target. Part of the reason is because these are things that we can't easily change. Although I can have my credit card company issue me a new credit card, it's very difficult for me to change my social security number, for example. Okay. And then the last main motivator we see is a desire to influence public perception. So whether this is creating fake reviews, votes, if it's plays that you want to have on the video platform of your choice in order to get that marginal cent per view payment, whatever that case might be. We have seen this with large, I'll just name it by name, but Amazon has had to tackle this recently with reviews of products and making sure that these are valid users and not automated reviews from any kind of a bot. Okay, so and they're not alone in that regard. So let's talk through a couple different attack types. The first one we're going to talk about is a distributed password attack. So rather than sit down and from a single source just try user and password combinations, what we're seeing more and more happen over the last few years is distributing this across numerous worker nodes. So whether these are machines that have been compromised with a virus and now can be put to the bidding of a bot, that's the most common thing we see, or infrastructure that's spun up specifically to try to leverage multiple IPs in order to attack websites. So you'll see these being aimed primarily at administrative users, or as it says here in the slide, high value accounts. So whether that's the CEO of a company, if you can score their email address somewhere, or whatever the case might be. And again, this is something that we see where the apps have high value data or that personally identifiable information on the back end. A second type of attack that we see happening more and more, and this one makes the news pretty often as well, is credential stuffing. So it doesn't take very much searching to run across samples of username and password combinations that number into the tens or even hundreds of millions. Then taking these combinations of usernames and passwords and rerunning them against a set of other applications is very, very common. Even folks like Mark Zuckerberg a couple years ago got hooked by this. He had a Facebook account with a very, very simple password that was compromised and published in a list like this. And it was also the username and password combination that he used for his LinkedIn account. So this happens on a very common basis, and this is why just about every security list that you see that says, hey, my family asked me what I should do to protect myself online, one of the number one items is don't reuse passwords. Okay, so again, the common targets are the ones that we all know about, be that retail, financial services, anything that's got any kind of ability to monetize it. Okay. So let's talk about another attack. This is the third of four that we'll talk through. So fake account creation. So nothing shocking here either. This is just where in an automated fashion, an attacker will sign up for a large number of new accounts. This puts them in a position where they can create those fake reviews or comments. And it also is a huge impact to e-commerce retailers. If you look around online and look at abandoned shopping carts, for example, you'll see estimates that this costs online retailers, e-retailers, something between $2 and $4 trillion. You'll see other numbers as high as $7 trillion. Those happen to be folks with a bit of a biased viewpoint because they're trying to help folks reduce that number of abandoned shopping carts. But even if these numbers are off by half, it's still an enormous amount of revenue that's abandoned in shopping carts. And this is a common way for, believe it or not, for competitors to be able to make it look as though their main competition is out of a particular item and can then be the source for that, even if it's not at a cheaper price. And the last attack that we're going to talk about is carding. So what do I do as an attacker, as a hacker, with all of these potential credit card numbers that we see advertised in the media all the time as being compromised? Well, on the black market, a validated credit card has a lot higher purchase value than just a list of credit cards. So what will happen is log into some random site that takes credit cards for small transactions, go ahead and run a single transaction through for a small amount, and know now that I have a valid credit card. These things are very, very sophisticated on the web, in fact. The companies, the organizations that are selling these credit cards will guarantee a certain level of validity, a certain percentage among cards that they sell. They have customer support portals. It is really big business. It just happens to be illegal. Common targets are, of course, anything that is retail fundraising. Think about the smaller type organizations that take credit cards for sign up that would potentially be more obscure and not tip off a larger fraud organization to the fact that credit cards are being validated. Those are the ones that are really, really commonly targeted. In fact, we had something happen just this week. There's a back in December, there was a disclosure of a convenience and gas station chain in the northeast of the U.S. that had been compromised for the previous 9 months or so. And just this week, starting Monday night, there were on the dark web about a quarter to half of those credit cards that had been stolen have gone up for sale on Joker Stash, if you want to dig in and read more about that. Okay. So let's talk about some case studies, things that we've seen over the last 12 to 18 months, and dig into these in a couple details in detail and talk about what we saw, how we were able to solve it, and then some best practices to avoid being a victim of an attack similar to these. So we're going to talk through these in the same way we discussed them. The distributed password attack. There's a digital graphics firm that is a customer of ThreatX who we saw a huge number of attempts to log into their administrative portals. So this company has a bunch of different brands that are all co-hosted. Each of them have a web portal on this basically mini provider's website, where you can do things like update inventory, create orders, and trigger print jobs on their industrial size printers and plotters. So our SOC saw a number of failed attempts spread statistically across IP addresses in a way that led us to dig into it further, and we saw that we were seeing something that was a botnet that originated from Ukraine and was targeted at trying to log into these admin portals. We were able to identify these and block this. This was a particularly slow attack where it was split across approximately 5,000 source IP addresses, and each of those IP addresses was only making a handful of attempts every hour. So it's something that a traditional web application firewall probably would not be able to identify. So we were able to block this. We're also able to do this not just on geolocation, but also on our ability to fingerprint entities and see individual actors, even when they are coming from multiple IP addresses. So how could we avoid this? The number one here, and I can't emphasize this enough, is put some multi-factor authentication on admin interfaces. This is very easy to do. There are numerous hardware and software tokens out there that will allow you to do this. If you're interested, do a quick Google search. There was a report from Google themselves last May that talked about the efficacy of multi-factor authentication. It is close to 100%. There are ways to circumvent some of the SMS two-factor authentication on cell phones, but using the dedicated app on a iOS or Android, or using a hardware token is very, very difficult to circumvent, and definitely put you in a position where you're not as attractive of a target as somebody that's not doing multi-factor. The other thing is to be sure that you're detecting any kind of login failures at a meta level, so that you're looking at the statistics of what's going on. Are you seeing a disproportionate number of failed login attempts? Is it different than what you typically see on your random Tuesday afternoon? Or is it something where you're typically 5 by 8 business day, 8 by 5 business day, and you're seeing a crazy number of things in the evening or on the weekends? And then need to be able to add dynamic protections based on attacker traits. So this is what we were able to do in conjunction with the geolocation, is to be able to look at things that were unique by the attacker's web browser or attempts to impersonate a web browser. So looking for things that were unusual, that were commonalities amongst those attackers, okay? So let's talk about a credential stuffing scenario. So again, this is a major online retailer that's a customer of ours. Again, a botnet that was kind of that moderate size, around 5,000 nodes, sending just a few login attempts from each of these IPs. The success rate of logins was very, very low, but you don't need a very high success rate for it to be worth your time. A single privileged login can be enough to make any of these kind of attacks worth your while as an attacker. And also because of the ability to rent botnets or build your own with very small investment, this is something that is becoming more and more approachable for folks that just a handful of years ago would not have been able to launch such an attack. So here we were looking at aggregate failure rates again. So, and we were also able to track distinct usernames and successful logins for each. So there are a number of databases out there that have consolidated compromised user credentials that are available for the white hat part of the industry. And we can then look, compare any kind of failure rates across any kind of successful logins across those databases to see, is this something where this username and password combo has been compromised and we really need to eliminate it from our configuration, okay? So that's what put us in a position where we were able to automatically then block those attacking nodes because we saw them using compromised credentials, and we're correlating that across multiple IP addresses. Pretty clear that Joe is not sitting in Boston and then 3 minutes later is trying to log in from Los Angeles or somewhere in Russia. Okay. So best practices to avoid something like this are, again, monitoring that aggregate login behavior across your applications. The second thing is being able to dynamically identify attackers based on users and their traits. This is something we'll talk about in some more detail here. And then, again, if possible, using some kind of additional verification for users, even if it's something lightweight like CAPTCHA or something like that. And ideally, if you're able, and it's not too much of a burden to usability, to implement multi-factor for customers. We see this happening more and more for high value accounts. So most of the online brokerages and banks will give users, especially their high net worth users, the ability to order a hardware token or install application on their phone to do that multi-factor additional authorization and multi-factor authentication. Okay. Okay, and now let's talk about a carding attack that we saw sometime in the last 6 or 9 months. So we have a large sports media site that has numerous media properties that most of which require a small subscription fee depending on what the particular service is. So customer signs up and is asked for the credit card information in order to pay that subscription fee. What it does here is we talked about that, and when we talked about a carding attack, is this puts the attacker in a position where they can confirm that these credit cards are still useful, that they haven't been canceled by the provider, and gives them, as we mentioned, far more value. The workflow was actually across multiple pages. So an initial registration page followed by putting in information, and then the actual credit card authorization was in a flow that was not through our sensors. But by watching the pages, we were able to identify this botnet because it had a kind of an unusual set of indicators. It used a really unusual set of request headers. The user agent and the browser language didn't look like a typical browser. That correlated with geographic and behavioral patterns let us identify these as illegitimate users and to block based on those criteria. Okay, and this is something that is huge for online retailers in particular, because it's very rare that an online retailer is going to be in a position where they can use a single indicator as a yes/no decision to block. So geolocation, most online retailers are interested in doing business worldwide. So geolocation is interesting as an indicator and as a risk component, but it's very difficult to use that as the only criteria for making an allow or block decision to your web application. So best practices here: when possible, if at all, use some kind of validation for user accounts when they are initially configured, whether this is via email, via text to a cell phone. Those things are possible to be defeated, but until everybody has these kind of controls in place, the attacker is going to move on to an easier target. Okay? And then the other thing is, again, being sure that you've got a tool in place at that application protection level that's able to profile workflows and identify things based on behavior rather than just an individual request, to be able to look at things over time and see combinations of behaviors and build a risk model that leads to a block based on that. All right, one more attack that we'll talk through what we saw. So this is actually an attack that we saw across a number of our customers. So this was a content scraping attempt that used some evasive type methods. And it's interesting. We see this on with growing frequency. So we have a customer that has online wholesale business that sells dental products, and they have before they became a ThreatX customer, had been victims of large-scale scraping efforts launched from within one of the major cloud providers. So this isn't something where you could use geolocation or IP space to block this traffic. It was launched from within, as I mentioned, a big service provider. And what was happening was they were scraping basically their product catalog and doing it from a number of IP addresses, so that each individual node of this botnet was pulling just a very small piece of the catalog, and it was being assembled on the back end. And what this did, at least the assumption is, that allowed some of these online pricing warehouses, as well as potentially their direct competitors, to present lower prices than this particular customer. So, especially things that are handled at the wholesale level, just a very small price difference can make an enormous difference to the bottom line. So being able to identify those type of attacks, especially when they're distributed, incredibly important. We saw this also directed towards a service provider of ours that had support portals as well as knowledge bases across their customer base. And this was actually being hit. They were actually being hit by a botnet that was using an anonymizing proxy. So this is a proxy network that our threat intel group discovered that has, by this time, hundreds of thousands of individual endpoints in it, and just pieces of it were being, we believe, rented and used to launch attacks at different customers that we had in order to use these scraping type attacks. And because they were behind anonymizers, all which came from domestic US IP addresses, it would defeat any kind of geolocation attempts, and the traffic, although it wasn't 100%, looked very, very close to traffic that you would see from a legitimate user. It was something that we were able to detect and block in an automated fashion. It did have a couple characteristics that made it be the behavior be identified and blocked, but it was very, very sophisticated. Okay. So best practices to avoid something like this is blocking Tor exit nodes and other anonymizing type proxies. Also, use those anonymizing proxies as a threat component. So there are some legitimate reasons for traffic to be using Tor or anonymizing proxies. They're typically corner cases, but again, it's not a single factor that you want to be relying on to make that yes/no decision. So to allow or block traffic, you really want to be profiling users and looking at their behaviors over time in order to make those block decisions, getting past just that binary yes/no transaction level decision. Okay. So let's talk about some strategies to automate our application security. We talked about the attacker side, but what about the detection and prevention side of the user of the issue? So at ThreatX, we really see an emerging market in the web application API protection space. So we've seen these kind of moves in other pieces of the security field over the last few years as well. We've seen a move to UEBA, so user and entity behavior analysis in the SIM world. Probably the most pronounced move we've seen is in the antivirus or the endpoint protection arena, where we've seen a move away from antivirus products that try to match on a set of static signatures that number in the millions of millions, and looking at a handful of behaviors, perhaps a few dozen behaviors, to identify malicious code that's trying to run on the endpoint. We see that same change happening in the web application security space. So being able to detect and prevent both known and unknown attacks, being able to look at combinations of behavior and block traffic that hasn't been seen before, things that are potentially running, trying to exploit a vulnerability that is a zero-day vulnerability. Moving beyond just anomaly tracking and looking at the behavior of entities, being able to fingerprint entities and identify attackers that are coming at us from hundreds or thousands of individual IP addresses and look at them as a single entity. Then we need to get away from the tuning of static signatures that is the trademark of this legacy web application firewall space. The second pillar we see in this next generation of web application protection is taking a holistic approach. So using a product that integrates web and API protection as well as bot and layer 7 DDoS prevention, and uses the intelligence that each of those facets uncovers to make the product as a whole that much more effective, sharing that information and eliminating that conga line of even tinier point products. And then the last thing is an absolute necessity to be cloud native. So an architecture that's every bit as at home being installed on dedicated hardware in a traditional data center as it is being deployed in the cloud, any of the big providers, as well as being deployed and orchestrated with things like Kubernetes or Istio Service Mesh and similar. And then an API first solution. Being able to do everything that can be done in the product with the user interface, having that be available via API so that you can easily click into any kind of automation and orchestration type initiatives. So that really that DevOps alignment and a rapid time to value. And again, to repeat, being able to put customers in a position where, regardless of where they're at on their cloud journey, they know that they can run the same set of tools, regardless of what their environment looks like, as they move more and more, potentially more and more of their applications into the cloud. So let's talk about that behavior approach that ThreatX uses. So you think about things in terms of escalating severity. You think of an attacker coming in and doing some recon, scanning, or mapping type activities. These are things that traditional solutions can't take decisive action on. They're making a yes/no decision based on, do I see these kind of behaviors? The ThreatX were able to use this as a time to fingerprint an entity and start watching them for up to 90 days, so that then when we see more malicious activity from an entity, we've got some context around what's going on. We've fingerprinted an entity. We have the ability to tar pit an entity so that if it's trying to attack a particularly compute-intensive piece of your web app, or maybe a very security-sensitive endpoint in your API, we can slow those attacks down and make them more expensive for an attacker. And then as we see those more malicious activities, we can block. This leads to us having very, very low false negative as well as false positives. Okay. You think about that risk over time, we're building a risk model around each entity, tracking that over time, and when it reaches a default threshold of 70 on a 100-point scale, that entity will be blocked. And what this does is allows us to block based on behavior, give up to 90 days of context around the behavior that we've seen, and really give visibility into why a block decision is made. Okay, so moving past the advertisement piece of this, what are the key takeaways here? 3 takeaways that we see are, number 1, make sure that your AppSec controls can handle, identify, and block malicious automation, right? Not a shocker, but absolutely the headline of this presentation is be sure that you're fighting automation with automation. The second thing is being able to find those abuses of application functionality at the attacker level, profiling attacker, gauging their behavior against the norm to see, is this a malicious or a legitimate user of my web application or API? And then the third piece, which ties into that, is automatically being able to distinguish those traits and being able to automatically block based on that behavior. If this is something that needs human intervention, it's something that's unlikely to get a timely response. This is absolutely something that needs to be handled in an automated fashion when you look at the scale of some of these small and even moderate size attack, let alone something that was of a larger scale. So with that, I'll flip back to see if there's any questions. And again, thank you very much for your time and attention, and for doing business both with Richey May and hopefully with ThreatX in the future.
Great, thank you, Mark. I'll stick around for a few minutes to see if there are any questions. Go ahead and type them in the chat box. I know sometimes it can take people a little bit longer to type it. Again, keep an eye out for the email with this recording and with the slide deck, and feel free to reach out to any of us. JT and Mark's contact information will be available in the slides and at the end of this video. So thanks again for everyone who attended.